All right, let's talk about math. But wait, not the kind that gives you nightmares about pop quizzes. Today, we're going to look at math as a toolkit, a set of powerful thinking tools that help you make sense of pretty much everything around you. So, let's jump in.
You know that feeling, right? You read a word problem, and it's just this jumble of words and numbers about somebody buying an insane number of watermelons. It feels like you need a secret decoder ring just to figure out what they're even asking.
Well, guess what? That's exactly what we're going to do. We're going to build a problem solver's toolkit, crack that code, and I'll show you how the logic behind it all can actually make your life a whole lot easier. Okay, first things first. The most important tool in our entire toolkit is simply this: figuring out what you're actually being asked to solve. Before you even think about picking up a calculator, you have to know the endgame. So take this fencing problem. A homeowner needs a new fence. A fence goes around the outside of the yard, right? So we're talking about perimeter. And to get that, all you need are the length and the width. The total area, the color of the fence, that's just noise. Extra information designed to distract you. Or how about this one? An age puzzle. You can see how everyone's age is linked to someone else's. Anna's age depends on Ben's, and Ben's age depends on Chloe's. It's like a chain reaction. You can't solve a thing until you have one solid number to start with. In this case, Chloe's age is the key that unlocks the whole puzzle.
And you know what? This same logic, finding the real goal, applies perfectly to algebra. When you see an equation like this, don't freak out. The goal is super simple. Get that x all by itself on one side of the equal sign. All you have to do is reverse the operations. It's like you're unwrapping a present, one layer at a time.
And here's the golden rule: balance. Whatever you do to one side of the equation, you absolutely must do the exact same thing to the other. So, since 5 is being subtracted from our x term, we do the opposite to get rid of it. We add 5, and we have to do it to both sides. That's our first step to getting x alone.
All right, so we've sharpened up our logic tools. Now, let's take them out for a spin in the real world with situations you're actually going to run into, like figuring out your paycheck or planning a road trip. At first glance, this might look a little intimidating, but trust me, it's just a simple 3-step recipe. First, you calculate all the money you earned. That's your gross pay. Then, you add up all the money that gets taken out, your deductions. And finally, you just subtract those deductions from what you earned to find out what you actually get to take home. And boom! There's our answer, see? By breaking a big problem down into small, bite-sized pieces, it becomes so much easier to handle. Let's try another one: a family trip to a concert. The best tool you can possibly use here is just good old-fashioned organization. By laying out every single cost in a neat little table, adult tickets, kid tickets, souvenirs, we can figure out each part on its own, then add them all up. It keeps things clean, helps you avoid mistakes, and makes finding the final change a piece of cake. Now, this slide is where it all clicks. This shows you the true power of having a math toolkit. Planning a road trip and figuring out a loan payment, they seem like completely different worlds, right? But look closer. They're solved with the exact same tool: division. In both cases, all we're doing is taking a big total amount, whether it's miles or money, and splitting it into smaller equal parts. Okay, so we've seen how to solve problems. Now let's pull back the curtain and look at the why. These are the master keys, the secret rules of the game that tell us how numbers have to behave. And once you understand these, you'll have the confidence to tackle any equation that comes your way. First step, we've got the commutative property. Just think of your daily commute. You can go from home to work or from work to home. The journey is the same distance either way. Well, in math, it means that for adding and multiplying, the order you put the numbers in doesn't change the final answer at all. Next is the associative property. This one is all about who you associate with, or which numbers you group together. If you've got a long string of numbers to add up, it doesn't matter if you add the first two together first or the last two. You can regroup them however you want, and you're still going to land on the same result. Oh, the distributive property is a really powerful one. I like to think of it like delivering mail. The number on the outside of the parentheses has to be distributed or handed out to every single number on the inside through multiplication. No one gets left out. Now this one is just refreshingly simple. The symmetric property is basically the mirror rule. If x equals 5, then it's also true that 5 equals x. You can just flip the two sides of an equal sign whenever you want and the statement is still perfectly true. It's all about balance. And finally, we have the transitive property. Think of this as the domino effect in math. If the first domino,
A, is equal to the second one, B, and that second domino, B, is equal to the third one, C, then you know for a fact that the first one, A, has to equal the last one, C. It's just a powerful chain of logic.
For our last section, let's toss a few geometry tools into our kit. We're just going to quickly look at the basic rules for how lines get along with each other on a graph.
So here we have two really important relationships. On one hand, you've got parallel lines. Think of railroad tracks. They have the exact same steepness, or slope, and they run alongside each other forever without ever crossing. On the other hand, you have perpendicular lines, which are the total opposite. They crash into each other at a perfect 90-degree angle, just like the corner of a square.
So after all that, after looking at all these different problems and rules and tools, what's the one big thing you should really walk away with?
It's this, right here. Math isn't just some subject you have to memorize formulas for to pass a test. It's a real, practical, everyday skill. It is a toolkit for thinking clearly, for breaking down problems, finding what's important, and coming up with a logical solution. And that's useful everywhere, from the grocery store to a board meeting.
So now that your toolkit is a little bit bigger and a little bit sharper, I'll leave you with just one last question to think about. What problem, big or small, are you going to solve today? Thanks for tuning in.